Okay, hi, welcome to the Excel for Statistics course. By the end of the course, I hope you will be able to perform basic business statistics analysis using Microsoft Excel. Then, through this course, you will also learn some of the benefits of using Microsoft Excel for daily needs, which will help you to be able to perform better at your job and your business. Okay, let me open the PowerPoint first. Okay, so welcome to the chapter 10, descriptive analysis and hypothesis testing, two variables. And then the first one, we will learn about the descriptive analysis. Okay, so descriptive analysis is an analysis conducted to assess the characteristics of a data. There are many characteristics, including mean, standard error, median, mode, standard deviation, sample variance, kurtosis, skewness, range, minimum, maximum, sum, count, largest, smallest, and confidence level. Okay, so let me explain some of the basic characteristics, which is for the first one, mean. Mean is the sum of all observations divided by the number of observations. It's best for the data that follow symmetric distributions. And then for the median is the value, okay, median is the value splits your data in half. Half the values fall off above the median, while half are below it. It is best for skew distribution. And then we have mode. Okay, so mode is the measure that represents the value that occur most frequently in your data. It's best for categorical and ordinal data. So that's all of the basic. And then we have uh, standard deviation. Okay, so standard deviation is the standard or typical difference between its data point and the mean. This measure uses the original units of the data, simplifying interpretation. And then we have sample variance. Sample variance is the average square difference of the values from the mean, because the calculation uses square differences. The variance is in square units rather than the original data units. And then for the range, here, range is the difference between the largest and smallest values in a data set. Okay. And then for the kurtosis indicates how to pick the peak and the tails of your distribution compared to the normal distribution. Okay, so I mean, this is just the basic of the basic characteristic. So we will learn about how to do the descriptive analysis in Microsoft Excel. Okay, let me share the Microsoft Excel first. Okay, so for the first one, we have this dataset. So I hope you are type this dataset into your Microsoft Excel. You can pause the video, and after you finish it, you can play this video again. Okay, I hope you already finished your data set. So we have grading in here from 78 until 94. Okay, so how to do the descriptive statistics in the descriptive analysis in the Microsoft Excel? So the first one, okay, so in the data tab, we choose data analysis right here, and then we choose the descriptive descriptive statistics. Okay, and click OK. For the input range, put the grading until the 94, and then labels, check the labels, and then we choose the output range for now. So when we choose the output range, we choose the cells that will appear the result of the descriptive statistics. Okay, for now I choose T3 in here, and then I can choose KTA largest, and then KTH smallest, and put OK. I click OK. For now, the result is the largest is 99, and then the smallest is 72. But for the others, data analysis, so we click the data analysis, choose the descriptive statistics. Okay, just uncheck the largest and smallest. Okay, sorry. Let me put in here. Output range, okay. Sorry, I think there's a problem in here. Summary statistics. Okay. So, okay. So I just put it in here, and then, sorry, the data before is because I choose the word. Okay, and then I put the largest and smallest just for the comparison. Okay, so this is the results. Okay, don't forget to choose the summary statistics in here. Okay, okay. This for this side. Okay, for this side, I don't check the largest and smallest, but for this side, I check the largest and smallest. Okay, so the result is for the descriptive statistic for this data set, the mean is 84.4667, and standard error is around 13. The median is 85. The mode is 79. The standard deviation is 8.2. And then sample variance around 67.9. And then for the cortices, minus 0.669. And then the skewness is 0.4, around that. And then for the range is 27. The minimum is 72. And the maximum number is 99. And then for the sum, the total is 102,067. I'm sorry, 1,267. And the count, the number of grading is 15. Okay, and then the largest is 69, and the smallest is 72. So this is the descriptive statistic. Once again, the descriptive statistics is an analysis conducted to assess the characteristics of a data. Then the next one is descriptive 2. Okay, so we have class A and class B in here. Okay, as you can see in here, class A and class B. So for the data set, I hope you already put it in your Microsoft Excel. But if you don't, just pause the video and finish it. And after that, you can play this video again. Okay, so I hope you already finished your data set. So we have class A and class B data in here. So class A, we have 78 until 94. And then for the class B, we have 81 until 85. Okay, let's do the data analysis. The descriptive statistics analysis in here. So we choose data analysis and then choose the descriptive statistics. And then for the input range, we choose class A until 85. So the two column in here, label in the first row, output range, we put it in E, okay, a summary statistic, largest and smallest, check, okay. So here's the results from two columns, okay. So for the mean of the class A is 84.5 around that, and then the mean is 82.2, and then the standard error is 2.13 around it, and the standard error for class B is 1.9, and then median for class A is 85, the median for class B is 82, and the mode is 78 for the class A, and the mode for class B is 87. The standard deviation is 8.2, and the standard deviation for class B is 7.2. Sample variance 87.9, and for the class A, and for the class B is 52.5. The kurtosis is minus 0.67. For the class B is 0.04. The skewness is 0.37 for the class A, and then 0.39 for the class B. The range is 27 for class A. The range for class B is 26. Minimum 72 for class A, 72 for class B2. Maximum 99 for class A, and for class B 98. For the sum for class A is 1,267, and then for the class B is 1,233, and then for the count 15 for both of it. For the largest is 99, 98 for class B, smallest 72 for class A, and 72 for class B. So that is the descriptive analysis. Okay, maybe you're asking how if we choose the new worksheet. Okay, so the new worksheet we can type descriptive. So it will be appear the new sheet for the answer of the descriptive analysis. So like this one. Okay, it automatically appears like this. Okay, so let's move to the t-test. Okay, so right now we will learn about the t-test. Okay, the t-tests are hypothesis tests that assess the means of one or two groups. Hypothesis tests use sample data to infer properties of entire populations. To be able to use a t-test, you need to obtain a random sample from your target populations. Depending on the t-test and how you configure it, the t-test can determine whether the two groups are different, the two group means are different, paired means are different, or one mean is different from a target value. Okay, so right now we will learn how to do the t-test, the three t-tests. The first one is paired two sample for means. The second one is two sample assuming equal variances. And then the third one is to sample assuming unequal variances. Okay. Sorry. Let me share the Microsoft Excel. Okay. So the first one is pair to sample for means. Okay. So we have before and after in here. So for the before is 78 until 94. And the after is 81 until 85. Okay. So as usual, please type the dataset first, and after that you can play the video again. So right now, how to do the t-test? Okay, in the data tab, choose data analysis, choose t-test pair to sample for means, click OK. Okay, variable 1 range before until 94. Variable 2 range is after until 85. Okay, put the label, put the output range, check the output range, put it into the E4 for now, and then click OK. And then the result is, so the mean before and after is 84 and 82. The variance is 67 and 52 for before and after. For observations is 15. The Pearson correlation is 0.064. The hypothesized mean difference is 0. TDF is 14. The t-stat is 0.82, and so on. So this is the result of the t-test paired to sample for means function in Excel. Okay, the next one, we will learn the other data. Okay, you can put the data first, and after that you can play this video again. And then we just the same like before. Okay, so for variable range 1, put in here. And then for variable 2 range, we put it in here. And then I just choose the new worksheet line. I just choose t-test. Okay, so this is the result. Okay, so this is the result, the mean, the variance, the observation, the Pearson correlation, and the hypothesized mean difference, TF, t-stat, and so on. Okay, so this is the t-test per to sample for means. Okay, so when asking what is the t-test per to sample for means, is the t-test used to test the difference in the mean of two variables from the same sample. Okay, so we just agree that this is the same sample. Okay, just before and after, so this is the same sample. Okay, the next one is the t-test to sample assuming equal variances. Okay, so this is a t-test that used to test the difference in the mean of two variables from different samples by assuming the two samples have the same variance. Okay, so we have grade 1, grade 2 data in here. I think this is the same like before, not much different from the t-test one. Okay, so you can just copy from the t-test one. Okay, let's do the data analysis to sample assuming a goal variance. Click OK. Put the range in here and in here. Okay, put the label, output range, E4, and click OK. So this is the results. The mean, the variance, the observations, the pool variance, the hypothesized mean difference, the TF, the t-stat, and so on. So this is the result of the t-test from this data set. Okay, from this example, yeah, we just doing the same. Okay, it's all the same. The variable 1 range, variable 2 range. Oh, it's different, I think. Okay, Sorry, let me change first. Okay, let me change it first. Okay, and then output range E4, the same. So this is the results of t-test from this data set for the mean, variance, observations until the degree critical to tall. The last one, the t-test to sample assuming unequal variances. Okay, so this is the t-test used to test the difference in the mean of two variables from different samples by assuming the two samples have unequal variance. Okay, so we have school A, school B data in here. The data is the same right before, so you can choose just use it. Okay, let's just do the data analysis. And then the sample assuming unequal for variable run range, we put the school A, and then for the variable 2, we put the school B labels, output range, we choose the E4 as always. Okay, and then this is the results. So we have mean, variance observation, hypothesized mean difference, DF, the start, until the critical to tail. So this is the result of t-test from two sample assuming unequal variance from this data set. And then the last one, we just try to put the new data set and then do the t-test to sample assuming unequal variance. Okay, just like that, and put the school B, just like that. Okay, all is the same. This is the results from this data set. Okay, so I hope our result is the same, not difference. And I think that's all for now. I hope you are learn much about how to do the descriptive analysis and then the t-test in Microsoft Excel. So I hope it will be useful for you. Okay, I think that's all for now. Thank you and see you in the next meeting.